morning students. Last class we discussed up to isoelectronic structures. Today we have to start wave characters. Before wave characters, briefly we discussed about Maxwell theory. What is Maxwell theory? How does electric and magnetic fields are producing? Electric and magnetic fields are produced by movement of charged particles. Movement of charged particles. Whenever these electric and magnetic fields are produced, these are in the form of wave. So these electric and magnetic fields first produced by movement of charged particles, and these can move in the form of waves. This is explained by Maxwell theory. Okay, these electric and magnetic fields, perpendicular to each other. For example, this is electric field. This is magnetic field. So electric and magnetic fields perpendicular to each other. This is electric, this is magnetic. One to another perpendicular to each other. Next point, these can move in the form of waves. Okay, oscillations. This is oscillations. Already you know in physics, oscillating natures. Next, another important point, these electric and magnetic fields perpendicular to each other and perpendicular to the propagandum of the wave. This is the Maxwell theory. Actually, don't read it neat, but just introduction. Before wave characteristics, just should know about the introduction. How does electric and magnetic fields producing? How does these are moving? Okay. Next, this is explained by Maxwell theory. Next one. According to Maxwell theory, waves, so the radiations, whether absorption or emission, in the form of waves, oscillations. Okay, here oscillations. This is called crest. This is called trough. So distance between two crests, then distance between two troughs. Distance between two crests or distance between two troughs is called wavelength. Okay, so for wavelength I explained this oscillation. Oscillation means when the radiations are emitted or observed, right, in the form of wave. So up is we call crest, down we have to call trough. So distance between any two crests or distance between any two trough is called wavelength. Okay, now again wavelength. It represents by lambda. Okay, wavelength means distance between any two crests or any two troughs. lambda. This is called lambda. Lambda. Okay. Generally units of wavelength. Meters, centimeters, like that. Units. But generally in light we have measurement in angstroms like that. 1 angstrom is equal to 10 power 8 centimeter or 10 power 10 centimeter. Next, 1 nanometer equal to 10 power minus 7 centimeter or 10 power minus 9 centimeter. Okay? This is about the wavelength. Important one, wavelength. Distance between two crest or distance between any two trough. This is about the wavelength. Next one, frequency. Frequency, nu. Nu, frequency. What is frequency? Right. These are oscillations. All are oscillations. Okay. For example, here one oscillation. This is 1 point. This is 1 point. This is 1 point. For suppose, for this point, how many oscillations are number of oscillations in 1 second? For example, this is 1 point. The number of oscillations in 1 second is called frequency. That means the number of oscillations per 1 second is called frequency. Frequency. It is denotes by or represented by nu.
Hey.
Nu.
Hey.
Units of frequency. Units of frequency. Units of frequency. Hertz. Second inverse or cycle per second. Cycle per second. These are the units of frequency. Okay? It is represented by nu. What is frequency? The number of oscillations per 1 second. The number of oscillations per 1 second. Then what is before wavelength? The distance between two crust or any two crust or any two trough. That is called wavelength. Okay. Next, characteristic of wave. Third one. Velocity. Now already velocity don't need to define. Just already you know it about velocity in physics also. Okay, 3 into 10 power 8 meters per second or 3 into 10 power 10 centimeters per second. In physics also already he knows about velocity. This is about wavelength, frequency and velocity. Here important one, relation. From here important. Before what I explained, that is just introduction. From now, very important, your need level. Okay? Relation between wavelength, frequency, and velocity. Velocity. Okay? This frequency. Velocity equal to wavelength into frequency. These formulas important in NEET level problems and further topics also. So for photoelectric effect, Planck's theory, okay, Einstein theory, these formulas are very important. Okay, frequency equal to velocity by wavelength, or wavelength equal to velocity by frequency, or velocity equal to wavelength into frequency. These are very important. Wave number newborn. This is called the newborn. Wave number represents by newborn. What is wave? Simple one. It is reciprocal of wavelength. It is reciprocal of wavelength. That means nu bar equal to 1 by lambda. Nu bar equal to 1 by lambda. Reciprocal means opposite. It is against of the wavelength. Nu bar equal to 1 by lambda. Okay. Then units. Say 1 by lambda. That means wavelength units oppositely just be write 1 by wavelength units. That means meter inverse centimeter inverse. These are the units of wave number. Just 1 by wavelength units. 1 by meter inverse. 1 by centimeter inverse. This is about the wave number. Then wave number applied to mu c lambda relationship. Already lambda equal to c by mu. Already know. Again, this is equation 1. Next, lambda equal to 1 by nu bar. 1 by nu bar. That means nu bar means wave number. Wave is the reciprocal of wave number now. That's a lambda equal to 1 by nu bar. This is second. That's why second equation is first equation. That means 1 by nu bar equal to right. Second equation in first equation. Okay, that means 1 by nu bar equal to c by lambda. Okay, c by nu. Finally, nu equal to velocity into nu bar. This is also another very important formula. That means frequency equal to velocity into wave number. Frequency equal to velocity into wave number. Okay, this is the simplest formulas. First, these formulas you know it means further easy. These are the characteristics of waves. What are the characteristics? Wavelength, wave number, frequency, velocity. Again, we have studied relation between them. Maxwell explained it. What is black body? Okay. Black body means according to Maxwell black body means which is the ideal body observe or emission. Emitted means release of. Observe means taking. Emitted or emission means releasing. Observe or emitted radiations in all frequencies. In all frequencies is called black body. Simple one. Black body means which is the ideal body observe or emitted radiations in all type of frequencies. 100 Hz, 500 Hz, 1000 Hz, 2000 Hz, 3000 Hz, whatever it is. Okay now, with some radiations, for example, red radiations, blue color, violet, yellow. These radiations at particular frequency only emitted or observed. Okay now, but black body, black color, emission or observed in all type of frequencies. Okay, high frequency and low frequency. Whatever frequency these radiations are, whether observed or released. Okay, that is called black body. Next one, very important topic. So, Planck's theory. Already you know about this theory is whatever we discussed. Just one time recall. What is the Planck's theory? Before Maxwell, everyone tell electric and magnetic radiations in the form of waves. Already they explained electric and magnetic radiations, whether observed or emission, in the form of waves. These electric and magnetic fields perpendicular to each other and perpendicular to propaganda of the wave direction. Okay, already they given. Then, according to Planck's theory, the radiations, whether observed or emissions, the radiations are produced by mobile charged particles. Okay, movement of charged particles. According to Planck's theory. Again, according to him, the radiations in the form of waves. Already Maxwell also same thing explained. In the form of waves, he given one extra point. What is that? The radiations emission are observed in the form of waves. Emission are observed. So he given one important point. The emission of radiations discontinuous manner. This is very important. Not continuously. Discontinuous manner. This is Planck's important point. Okay. by movement of charged particles. So already Maxwell given. Again he also given, but he given two good points. What is that? The emission of radiations in discontinuous manner. That means whenever radiations are emission, not frequently come, not continuously come, discontinuous manner. Some radiations come, stop, and again some radiations come, like that. So not frequently come. So the emission of radiations discontinuous manner. Again given these radiations in the form of small packets, in the form of these radiations, the emission of radiations in the form of small packets are called quantum. Quantum means, according to Planck's theory, the emission of radiations in discontinuous manner and in the form of this discontinuous manner in the form of small packets. Okay, is called quantum. Quantum means the emission of radiations in the form of wave, and these emission of radiations in discontinuous manner, and discontinuous manner means not frequent. Packets means small pieces. So these emission of radiation small pieces. So he called that is small packets. That packets are called quantum. Okay, these two important points Planck's given. Next to another one, according to Planck's, right, the emission of radiations, radiant energy. Radiant energy means radiation energy only. Radiant energy means radiation energy only. Emission of radiations energy associated with frequency, nu. That's why E directly proportional to nu. According to Planck's, energy associated with frequency. That means energy directly proportional to frequency. Energy has directly proportional to frequency. Instead of directly proportional, we take one constant h. So h is the Planck's constant. Instead of directly proportional, we take one constant, that is h. H is the Planck's constant. So E equal to h nu. Already we know nu equal to c by lambda. This is equation 1. This is the equation 2. Equation 2 is the equation 1. That means E equal to h into c by lambda. Equal to h into c by lambda. This is the Planck's theory. Okay. Then finally we got E equal to h into c by lambda. fixed value. He given one fixed value for Planck's constant. So fixed values you should remember. In sums or problems in exam they didn't given. You only remember and apply in exam. Okay, the value h equal to 6.626 into 10 power minus 34 joules are 6.626 into 10 power minus 37x minus 27x. Okay, just some approximately take 6.625 also no problem in sums time. While you doing sums, 6.625 also take no problem. Exact value this one. 6.626 into 10 power minus 34 joules or 6.626 into 10 power minus 27x. This is the Planck's theory. Next, following the Planck's theory, one small theory is Einstein theory. Einstein theory. Einstein theory. Einstein's theory. Einstein's theory. Okay. Listen, students. According to Planck, the energy emission, that means the radiation emissions in the form, otherwise emission of radiations in the form of wave, according to Planck's theory. Okay, he explained discontinuous matter, small particles, do that. But according to Einstein theory, the emission of radiation in the form of small particle. This difference you should observe. According to Planck's theory, the emission of radiation in the form of waves. According to Planck's theory. According to Einstein theory, the emission of radiation in the form of small particle. Okay, that small particle is called photon. Not proton, photon. Photon. Okay, this is the Einstein theory. Okay, according to Einstein also, one formula is there already. You know what is the Einstein formula? Equal to mc square. Energy of radiation directly proportional to square of the velocity equal to mc square. This is the Einstein theory. Then Einstein also explains energy, the emission of radiant energy directly proportional to frequency. Planck's also same explain. Planck's also E directly proportional nu. So Einstein also explained E directly proportional to nu. So the radiant energy directly proportional to frequency. Same Einstein also explains same thing. Next, both formulas relation. What is the first one? Equal to h nu. This is the equation 1. Here h nu means equal to h into c by lambda. Here nu equal to c by lambda. Okay. This is equation 1. What is Einstein formula? Equal to mc square. only. Okay, that's why equation 1 equal to equation 2. That means h into c by lambda equal to mc square. Here 1c cancel. That means h by lambda equal to mc. H by lambda equal to mc, mass into velocity. Okay, now finally lambda equal to h by mc, wavelength equal to h by mc. H means Planck's constant, by m means mass, c means velocity. So lambda equal to h by mc. Okay, now so your wave nature plus particle nature both combined. Wave nature plus particle nature. Wave nature by Planck's theory, particle nature by Einstein. So we both mixing. So lambda equal to h by mc. Again, lambda equal to c by nu. Already we know it. Lambda equal to c by nu. So this is for example equation 3. This is equation 4. 4 in 3. 4 in 3. That means both are lambda only. Okay, now that's means instead of lambda we apply c by nu equal to h by mc. H by mc. Then cross multiplication means h nu equal to mc square. Finally h equal to mc square by nu. mc square by nu, or nu equal to mc square by h. These are the derivations. The small formulas are derivation. The small formulas. Okay. Regarding these formulas, sums next class we will discuss. 5, 6 sums, 4, 5 sums. We have practice means easily you can understand. Okay. In NEET exam, sums only coming. In NEET exam, on these formulas, sums only coming. Next class we will discuss. Okay, students. Next class we will discuss some sums and we will go to photoelectric effect. Once photoelectric effect completed and spectrum completed means first introduction part completed, physics part completed, introduction part and physics part. Then we will go to Bohr's theory. From Bohr's theory, pure chemistry will start.